David, did you already think I'm gonna lose my bet?
No, I have two plans, one in case of another. Like, you're just better to be prepared. I learned that
Basically,
in
you're
Scouts.
saying there's a chance you're gonna lose.
No. And honestly, if you asked me a week ago, I would have said 100% I thought we would be shut down those Monday and Tuesday. But now I don't think we will at all. What's that? If that. And Bear River has a ton and they didn't shut them down. I don't think our district cares anymore. I don't think they care anymore. I don't know. I can't answer that. But I don't know that we'll shut down ever. And I'm a super negative person, like pessimist. And every time I've tested, I've been negative. Weird. Okay, moving on. We got a lot to do. Bond Enthalpies is math. It's the same stuff we've done before. Tomorrow, balloon activity. Wednesday, electron domains and molecular geometry. Thursday, polarity, hybridization, and sigma and pi bonds. If the winds are blowing in the direction that we won't be here Monday and Tuesday, then we're going to test Friday. What? Review? If it depends on when we take the test. Oh, whoa. No review. We'll take it Friday. Okay. Now, once again, I do not think we will shut down, and I'm usually the most pessimist human I know. So let's just do it. I got 9 people that turned in. No, that's not right. That would be 6, an upside down 9. 6 people that did their homework. That was awesome. I know. You guys are awesome. Yep, the Lewis structures. I know. Okay. You don't need to tell me if you did or not. I know who did because you turned it in. Cool how that works. All right, here we go. As I looked at the AP classroom thing, only the highest percentage of video that was watched was 33%. So 2/3 of you aren't doing anything. That's your choice. That's fine. Those videos I asked you to watch. And then, yep, there was 3 of them. Now, I added some, please. Hold on. If you go to your Canvas course, they left a message that fast. All right, right here. And you can access them through your AP classroom as well. But if you go to chapter 9 readings, down at the bottom, Vesper, AP classroom videos, and PhET simulations. I've assigned these 3. These will help you a ton. You don't need to plug them in. Okay. These 3 videos, they're not very long. You may need to pause them and write notes, but they will really help you with what we're going to try and blow through the next 3 days after today. And then he uses a thing that's kind of cool while he teaches those videos. So it's just these where you can drag around and look if you feel like it. You can click those and bond angles and all that stuff if you feel like it. So that's on there. When you watch his video, if you look at it like, hey, I want to look at that, it's this right down here. Okay, but today is Bond Enthalpies. Once I figure out who is texting me like 10 times. Yeah.
It's a really big fight.
Reese, you want to fight?
Yeah.
You're supposed to help with the next 3 days. So maybe I'm not. Reese does have respect. Oh, she'd hand me I honestly wouldn't try because I feel like if I got more beat up and started to fight,
If you beat someone else, so
Hey, how do you spell the first part of Punnett squares? Oh, there's 2 T's. I was so close.
y'all could
Okay, here we go. Genetics, which I haven't done since 1991. Okay. Bond enthalpies. You can't do bond enthalpies unless you know how to do Lewis structures. Like you can, but you'll get the wrong answer 100% of the time. So please work on your Lewis structures still. There's the practice ones I gave you. Whatever. If you get stuck, I want to look it up, which most of you probably looked up how to do N2O5 because it's a little tricky. Bond enthalpy. Most simply, the strength of a bond is measured in how much energy it requires to break the bond. All right, this is the bond enthalpy. Bless you, bless you. Enthalpy is delta H, if you remember. So this is a third way to calculate the same thing we've already calculated 2 other ways. So the bond enthalpy for the CL-Cl bond is measured at 242 kilojoules per mole. All right, you don't have to have that memorized. It's just saying when we break this, we get this much energy out. All right, or sorry, we put that much energy in to break the bond. Okay, now this table, I know it says whatever. No, it doesn't. This table lists the average bond enthalpies for many different types of bonds. Average bond enthalpies are positive because bond breaking is an endothermic process, which would mean bond forming is a exothermic process. All right, whenever you do these problems, you will always have a data table given to you. All right, if it was in your book, it'd be Appendix A. You would just turn to the back and you'd look at it. If it's on a test, there'll be a table given here. All right, this is important to realize. These are average bond enthalpies, not exact. All right, so the CH bonds in methane will be a little bit different than the CH bond in chloroform, just because the bond length and the things that are around. We'll learn a little bit more about that in chapter 9. But they're just averages of all of them. Okay. All right, so, well, we're after it. Okay, thank you. That's a very fancy printout. It's for Judah. Oh, good catch. All right. I feel like there's more notes before we do an example problem, but maybe I'm wrong. Okay, so here we go. Yet another way to estimate delta H for a reaction is to compare the bond enthalpies of bonds broken to the bond enthalpies of the new bonds formed. All right, this did not come in very good. So look right here. This is similar math to what we've already done. So to find the delta H for a reaction, we find the sum of all bonds broken and subtract the sum of all bonds formed.
Hello, everyone. It's Christmas Assistance Week.
Okay, using this equation and the tables we just looked at and our Lewis structures, we can figure this stuff out pretty easy. I mean, it's like tedious, but it's not hard. Yes, Judah?
On our slideshow, when we have to form this, that triangle, the delta's not there. Like, it's just a weird box.
Right here?
No.
Right here? Oh, I'm sorry. If I delete all this, this is what the triangle turns into here. So, all right, now, so let's come to this page and we'll do an example here. Please write out this whole example with me. So we want to know the delta H for the reaction of C2H6 burning, which means it reacts with O2 to produce CO2 plus H2O. Okay, the first step is pretty much the same as always, and that's to balance it. So take a minute to balance it. You may remember combustions can be done really fast if you remember. I'll wait just a minute. Okay, I do it personally by always starting with the 2, then doubling, then taking the 6, then adding. 8 plus 6 is 14, dividing by 2, and I get 7. Anyone else get 2, 7, 4, 6? Okay, sorry I went too fast. Will someone shut that door? I hear AP Bio way better than AP Chemistry right now. All right, so here we go. What we need to do now, oh, I know you can be loud. The next thing we're going to do is we're going to draw the Lewis structure for every single one of these here. So C2H6, it's not super hard. That one was bad. Okay, well, I just want to get rid of that one. Okay, off of each of these lines is an H. Nope, no dots are needed. It works out really well.
Hydrogen's my favorite for Lewis structure.
Yeah, they're nice, huh? Okay, plus O2. What, Judah?
What about the 2?
We'll worry about the 2 in a minute. All right, then I have 7 oxygens, but I'm just going to draw O2 bonded to itself. You may remember, like I hope you do, that it's double bonded to itself. Okay with that? Now, you can put the dots if you feel like, but you don't need to. Bless you again. I hope it's just allergies. All right. CO2. Hopefully you have that memorized as well. It's an O, double bonded to a C, double bonded to an O. All right. Once again, if you feel like it, you can put the dots, but for this process, it's not necessary unless like you just want to double check that you did the structure right. And then water. And then for the third time, you don't have to draw the dots unless you feel like it. All right. Now, this is the structural formula for this. I could write this twice, this 7 times, this 4 times, and this 6 times. I could do that, but I'm going to choose not to do that. I will incorporate them somewhere else. Okay, so this is what you do next. You look at each type of bond that will be broken. So I need to break 1, 2, 3, 4, 5, 6 carbon to hydrogen bonds. Are you okay with that? Well, don't say anything yet. Are you okay with that? Now, my friends, that really happens twice. It happens 2 times. Where you distribute this to could be up to you, but this is the most thorough way to do it. Okay, plus, now we're still here. I have 1 C2C bond. Oh, that was funny. Are you okay with that? But that C to C bond happens twice. Does everyone know where the 2 came from right here? Does everyone know where the 6 came from? 1, 2, 3, 4, 5, 6. This 2 from here. This 1 from it happening 1 single time. Okay, now that's not all of the bonds broken. there is also one O to O double bond. But how many times does that happen?
7.
That happens 7 times. Now you don't have to write it out this way. You could just make that a 7. I just do this for emphasis. Okay, then I need the sum of all of this, right? Minus the sum of all the ones that are formed. Okay, keep following me here. I have, look at the board, 2 C double bond O bonds to break. But how many times did that happen? 4 times. Now, once again, I'm fine if you just do that math in your head. If you write an 8 right here, that's fine. I'm just drawing it so you can see the actual process. All right, and then in water, I keep saying break, sorry. I form, this is the forming side. Either way, the numbers are fine. I have 2 O to H bonds, but that happens 6 times. All right. That's the sum sign, and that's the sum sign. Okay, now you don't have to do this step because maybe you already did. I'm going to clean this up by just doing 2 times 6 is 12 C to H. Plus 2 times 1 is 2 C to C. Plus 7 times 1 is 7, O double bonded to O. Now, once again, you may have already done this. I'm just trying to be thorough here. I have 8 C double bond to O plus 12 O to H. All right. Then I'm going to plug in my numbers. I have 12 times C to H is right here. 413. What the dyslexia in the world?
14.3.
413. Plus I have 2 times C to C. Is it 348?
Yeah, it's 348.
348 plus 7. You'll typically find O double bond O just written as O2 in a table. Minus 8 C double bond to O is 799. It's right here. It's hidden. Yep. Yeah. All right. Plus 12 times my OH, which is 463. Now, I will warn you that kids traditionally are terrible at math. Make sure you do this entire thing, and then subtract. If you don't do it with parentheses, you will not get the right answer. You should get a negative number. This is an exothermic process. So that's exactly typical. We have 3 people with 2 different answers already.
Well, majority rules. I say
Let's wait for a third.
we got a third. That's how math works.
I would borrow one with parentheses.
I have
I
all my
can't handle
numbers.
not having correct.
As I a scientist, I refuse to be dumb, called incorrect. So, until someone is this C partial, you can never prove something right, you can always prove something wrong. Exactly.
Is it what?
Until I prove wrong. I have 99.
Yeah.
There you go. Thank you. No
I
problem.
thought I was 795.
Yeah. So,
Okay, we have so far a what, Bennett?
negative 2,031.
Yep. All right, now we got 3. That's majority rules. Yeah, I got
Majority rules, okay.
Okay.
So unless you got it all wrong, I believe we are right.
Let me look at something.
He's trying to add it up. He's like, somewhere else.
I'll come back, don't worry. Yeah.
Negative 2,831. Yeah.
Okay, how fun was that? Good.
I actually like these ones. They listen. Let's only do this one today.
All right.
Say that every time, baby.
It's my AP virus slogan. Like how my AP virus slogan was for my mitochondria. This one is, let's only do this on the day.
I need another blank in a chart. All right, we ready? All right.
So first balance.
So hold on.
We see them leave on sons and calculus.
What?
Leave on sons. They're kind of like this. They are. That's where parentheses are your best friend.
Now, this one you might think, Davidson, this is exactly the same as we just did, but no, it ain't. This 4 versus a 6 does make a difference. Not a ton, but it does make a difference. Okay, I'm going to pause the video. You guys take a few minutes and oh, it's not that big a deal. We just need the answer because I did everything up until the answer. All right, friends. It was this one. So if you're watching online, I think everyone's here. Nope, she's not. Hey, JC. Future people, the answer was negative 1297. Kilojoules, don't forget units. All right, now chapter 9. I probably never put it on there. The blue sheet is not due. I can add it, I just keep forgetting. All right, chapter 9 has 3 topics. 1 is extremely important, and 2, they're not necessarily, I shouldn't say important, but like you have 110% chance you'll have to do this on the AP test. You have like a 10% chance on these 2. Oh, this, so do I, but it's not that bad. So please, chapter 9, it would behoove you quite a lot to read through, especially the first 3 sections. Watch those 3 videos and you can really learn all of it. It's not hard. All right. So molecular geometry, then polarity, then hybridization. Tomorrow we will do an activity with balloons. It's crazy, but just blowing up balloons and tying them together can teach us the exact same things here. All right. So we're a little ahead, which rarely happens. If you feel like it, I don't care. So we'll do this tomorrow, but let's just dive in. Well, you can do this right now if you think about it. The FBF bond angle in BF3 is approximately blank. So the process for you to do this is going to be involved in this chapter. You draw the Lewis structure, which you may remember look like this. I'm going to leave off the dots, but this is one where we left boron hanging without an extra pair, correct? So we're going to learn that means that there are 3 places that electrons reside around boron. Electrons, let me talk, everybody. We have 3 total things. So we divide our circle into 3 parts. So 360 divided by 3 equals 120. Now, what's that? They're not angled down. We'll learn. They're not angled down because there's not an unshared pair anywhere. This one we will learn is trigonal, planar, and they are 120 degrees apart from each other. All right. So we'll do that tomorrow. A molecule's shape, or sorry, I should just read it how it's written. The shape of a molecule plays an important role in its reactivity. Like we would never think about that, but this is super important. By noting the number of bonding and non-bonding electron pairs, we can easily predict the shape of the molecule. So by the end of the week, this really should not be very hard. All right. When we talk about the pairs of electrons, we're going to call them electron domains. Domains just means where they live, where they reside. All right. So that we determine these by drawing the structure and counting up everywhere where there are electrons residing. So what determines the shape of a molecule? Simply put, electron pairs, whether they be bonding or non-bonding, repel each other. So they push each other away. By assuming the electron pairs are placed as far away as possible from each other, we can predict the shape of the molecule. So here we go. Like we draw NH3 right here. It has an N. It has this non-bonding pair of electrons that occupies space. Then it has three H's that bond to it, but they are repelled a little bit downward from that non-bonding pair. So that's supposed to sort of try and show you a 3D model of how this would look. So we might look at it on paper and just assume that it's made like a T, but it's definitely not like a T. It has 4 electron domains. It has 3 that are bonding and 1 that is non-bonding. Whenever we have something with 4 electron domains, its electron domain geometry is called tetrahedral. Now, you don't need to write this down because it'll be all over the notes coming up. All right. Whenever we have a tetrahedral electron domain geometry, but we have at least, well, we have, sorry, 1 non-bonding pair, our molecular geometry turns into what we call trigonal pyramidal. No, I'm not sure I spelled that right. Trigonal means 3 things come out of it. Pyramidal means they're not on the same plane. It's not flat. It's bent. Like this thing would look like a phone stand. Like imagine this is holding your cell phone right here with the tripod. Okay, they bend down and away. All right, so the shape, I can hear the chairs moving, is determined by first finding the electron domain geometry and then accounting for non-bonding pairs to find the molecular geometry. It's a very pretty simple process. So we can refer to the electron pairs as electron domains. In a double or triple bond, all electrons shared between the 2 atoms are on the same side of the central atom, therefore they count as 1 electron domain. So what this is saying is around A, we have 1, 2, 3, 4 electron domains, which means that it is tetrahedral. All right, but we have 1 non-bonding pair, so that wouldn't be represented in the molecule. So we'd have B, B, and B. A would be like the knot that was tying all these balloons together, if you're with me. All right, so we'd say that the electron domain geometry of A is tetrahedral, but once again, it is trigonal pyramidal. And that's because this non-bonding pair. Now, this is drawn, that's kind of dumb. It should be rotated based on how that picture, oh, screw it, but you get the idea. Okay. Next, well, we got 20 seconds. Okay, tomorrow we're going to tie a bunch of balloons together. If you're allergic to balloons, I'm sorry.